Hello, I am Rotuxel. I will do a geospatial workshop in this video. I will use Hibernate-Spatial, Spring Boot, and PostgreSql with PostGIS technologies. Let's look at our outline. First, we will start with generating our base Spring Boot application. Next, we will save JTS Geometry objects to PostgreSql with PostGIS DB. And then we will convert JTS geometries to GeoJSON and vice versa. And then we will create custom JSON serializer, deserializer for JTS geometries. And finally, we will perform some geospatial queries. Alright, I use Spring Initializer to generate our base Spring Boot application. I selected Maven as build tool, Spring Boot version 2.7. I select Java 11 and Spring Web, Data JPA and PostgreSql driver as dependencies. And I will use ultimate-geojson library to build and parse GeoJSON. I am the author of this lib and you can visit this library on my GitHub repo here. Okay, let's start with our base project. I pasted all needed property values here. We need to configure our data source to connect to our DB. We will use this PostGIS dialog to be able to work with geospatial capabilities. And I set DDL auto to create. Don't do this on prod DBs because it will create all tables corresponding to entities defined from scratch on each startup. We need to add Hibernate-Spatial dependency into our POM.xml file. So search for Hibernate-Spatial Maven on Google and get the Maven dependency definition. Copy and paste to POM.xml. We will get an error, but let's talk about after we get the error. We have a different version of Hibernate core, so we need a compatible one. Find Hibernate-Spatial with the same version of Hibernate core and copy paste dependency definition. Let's start the app. And yep, it's working now. Let's define our sample entity. I will name it Spatial Lab. Let me copy and paste fields to save some time. Here are JTS fields. I generate getters and setters. Point, multi-point, line string, multi-line string, polygon. And please be careful to import from correct packages because there are lots of point classes out there. we need this point class from JTS packages. So what is JTS? Let's search on Google. JTS Topology Suite is an open source Java software library that provides an object model for planar geometry. Let's look at features. And here is geometry model classes. Hibernate-Spatial is supporting these model classes in object relational mappings. Let's run the app and see create table SQL. And here is this. All fields are mapped to geometry columns. There is also an option of geography column, but it is a bit more advanced topic, and let's continue with this basic geometry column. Let's see on DB also our table and columns, and here are columns. There is no item yet. Let's save an item. I will create an init service now. I will save an item on each startup if there is no item saved before. I will name it Init-Spatial Lab Service. It will implement application listener and it will listen application ready event. Of course, I need a component annotation and I will give order of 1. I will implement the needed method. And to save an item, I need a repository class, right? I will create a repository. I will name it Spatial Lab repository. It will extend JPA repository and will give Spatial Lab entity and long as generic parameters. And I will auto-wire the repository in this init service. First, I will check if there is already an saved item in DB, and if there is one, I will return and do nothing. And if there is no item saved, I will create an item. Let me copy and paste initialization codes for the time being. Yes, in JTS we can create geometry instances using Geometry Factory. Here are some examples to create point, line string, and polygon. And at the end we save entity using the repository here. Let's rerun the application and see the insert query. And here it is. Let's see also on the DB view our recording. Yes, it is saved here. Alright, let's check the outline. We started our base Spring Boot application. we saved JTS geometries, and now we will convert JTS geometries to GeoJSON using ultimate-geojson library. Search ultimate-geojson on Google, and here is my repo, ultimate-geojson. You can use this library to parse and build GeoJSON. We will use JTS conversion util here in our project. We will copy the GitHub URL and pull into our own machine. We will run maven install. And yes, the new JSON artifacts are installed into our local maven repository m2 directory, as you can see here. And now we can add GeoJSON dependencies to our project. Alright, it's there. GeoJSON math builder and parser artifacts. Let's check under external libraries. And yes, they are here. And now I will create an integration test class. In it, I will load the saved item and convert its JTS geometries to GeoJSON strings. I will auto-wire Spatial Lab repository and load the saved item. I will hardcode the ID, of course, for the demo purposes. I am getting point and polygon geometries. I will create a JTS conversion util instance. By using this util, I will convert JTS geometries to GeoJSON POJO classes. Point DTO and polygon DTO will be our GeoJSON POJO instances. And after that, we will use them to generate JSON strings. JTS conversion util has also some generic methods which we can pass any type of JTS geometries. As you can see, these point D2 and polygon D2 are GeoJSON project classes. With using this ultimate GeoJSON builder, we can create GeoJSON strings from project instances. I will print them out on the console and I will visualize them. Okay, let's run the test and see the results. Here are GeoJSON strings, point and polygon. I will copy this polygon GeoJSON and I will use GeoJSON IO website to visualize our GeoJSONs. I will paste it to here and it will convert to a feature collection, but no problem, our geometry string is here. That's it. We can also convert GeoJSON strings back to JTS Geometry instances. Let's see how we can do it. I convert GeoJSON string to new GeoJSON POJO instance and I will use that POJO instance to convert JTS Geometry. I will debug the test and we'll see the geometry instance. And yes, it is JTS polygon. Alright, next step in our outline is creating custom JSON serializer and deserializer. So why do we need them? Let's implement a REST controller and try to return spatial lab item. I will name it spatial lab controller. REST controller annotation is needed here. And I give a request mapping of spatial. I will define a get mapping here. I will get ID parameter using a pet variable. I will auto-while repository here. Okay, using a repository directly in controller is not a best practice. But just for the time being, I will break the rules here. Don't do that on real-world projects. And moreover, normally we don't return directly entity instances in API endpoints. But for just demo purposes, I think it's fine. Let's try this API endpoint. Oops, as you see, Spring Boot application cannot serialize JTS geometries properly. These JSONs are useless. I want to make application convert JTS geometries to GeoJSON and return them on the fly in cases like this. So how we do that? We create a class named custom view GeoJSON serializer, and it will extend JSON serializer. Define JTS Geometry class type for template parameter because it is the parent class of all JTS geometries. Implement missing method. And here we go. We will use JTS conversion util here. We will convert JTS geometry to ultimate-geojson project class and convert that project class to GeoJSON string, and finally write that string to response. Okay, our custom serializer is ready, but how will we put it in use? We need to define a config class, and in it we need an object mapper bean definition. We need to put a configuration annotation here. Define an object mapper. And define a simple module instance. Add serializer in it. By this way, we say that whenever you try to serialize a geometry class instance, use this custom serializer. And register the module and return the mapper. Let's try again. And here it is. We now have GeoJSON in API response for each geometry, point, line string, polygon, etc. So what about the serializer? Why do we need it? Let's see. I will define a post API endpoint to get GeoJSON in the request body. Let's see what will happen. And again, for being fast, I will use special live entity class as request body DTO and save it in controller class via repository directly. This is not the best practice. Normally we should define a request body DTO class, and we should have a service implementation which will handle save operation in it. But okay, this is a demo. Let's continue. Let's draw a polygon on GeoJSON.io website. I will get the geometry GeoJSON. Prepare a request body on Postman, and I will send the request. Here is our geometry, and the generated GeoJSON is here. And on Postman, I will prepare a request body to send a polygon GeoJSON. And here is the error we expect. Our app cannot deserialize GeoJSON to JTS Polygon instance. Okay, we will resolve this by defining a custom deserializer. Create a class named custom-geojson deserializer. Extend it with JSON deserializer. Define JTS Geometry class type for template parameter, because it is the parent class of all JTS geometries. Implement the missing method. We need to extract GeoJSON string from this JSON parser. And we will use ultimate-geojson library here to convert this GeoJSON string to JTS Geometry instance. We will use this generic to JTS geometry method here. And yes, our deserializer is ready. We need to put it in use in object mapper definition. Add a deserializer in simple module definition. We have a problem here, and I think our app couldn't detect our deserializer. We need to give deserializer class more specifically. For this example, we need to give polygon class. And I will make this deserializer generic to use other geometry types. We will need to add this custom deserializer for each type, for example, point, line string, multi-polygon, etc. Okay, it is ready now. Let's retry. Yes, it worked. Here is the insert statement. Let's see also on DB1 our new record. Because we only sent polygon field, we have only polygon definition in the item. Let's visualize our saved item. I will get using the second ID, copy the GeoJSON, and I will paste this GeoJSON IO. Alright. Okay, what's left? And let's make some geospatial queries. Search for Hibernate-Spatial queries documentation. Go for the version 5 documents. And here it is. These functions are supported by Hibernate-Spatial. Let's try intersect function. I will change DDL auto configuration from create to update because I don't want to lose my saved items on each restart. I will save some polygons here. One for Ankara and one for Istanbul. Let's see on the viewer, and here it is, our Istanbul and Ankara polygons. We will make queries to get these items. Open repository class. We need to define custom query using add query annotation. Select as from spatial lab as where intersects as polygon and our filtered parameter equals true. This query will return items that our filtered parameter intersects with items saved on DB with that polygon columns. And to use these, we will define an API endpoint in our controller. I will make a post mapping because I will get a filter polygon in the request body. I will name it get intersects. Again, this is not the best practice to use repository in controller. Okay, let's try it. I will draw a filter polygon from a faraway geography. I will use Postman to send my request. It stopped at the breakpoint, and here is our filter polygon. And as we expected, there is no intersection, this faraway polygon. Let's try with a really intersecting polygon. And here it is, our saved Ankara polygon here. Let's try with Istanbul also. Yes, it returned. Okay, next, let's define a query for finding polygons within a given distance. Select S from Spatial Lab as, where as the distance sphere function and parameters will be as polygon and our filter parameter. The value of this distance sphere should be lower than our distance parameter. Unfortunately, Hibernate-Spatial is not supporting this ST distance sphere method. Find near within distance method. This method will need two parameters, one for filter geometry and one for distance. Distance will be in meters unit. We need an API endpoint for this query. Get near within distance polygons. And I will get distance parameter as path parameter. And because I want to use point type as filter, I need to add a deserializer for also point class. There is a problem here, and I think some kind of typo error here. Yes, here it is. Let's see also our generated queries when we use geospatial queries. Okay, let's draw a point here as filter geometry. Prepare the request body and give 100 meters as distance parameter. And as expected, no polygon within 100 meters. But there is a problem here. I need to pass the point geometry here because I am sending point in request body. Let's try by increasing our distance parameters. When we come to 100 kilometers, we have result. I think we get the Ankara polygon here. When we increase to 1000 kilometers, we also get this Istanbul polygon in the response. And Here is the select query generated when we use this within distance query. And we will come to the end. I hope this tutorial is beneficial for you and helps you to understand basic geospatial software development. Feel free to ask questions or suggest topics to cover on next videos on comments. Subscribe to channel to get more quality content. Thank you for watching.